How important was it to find out how the human body worked, or how to keep time, or how to create antibiotics, or how to help people see better? Would knowing 75% of any of these things be enough to stop searching for the answers? For centuries, astronomers have used scientific theory to find explanations for the unknown, and we're still searching for the unknown, the dark matter unknown. We know it's there. The evidence is so strong it's become more than an experiment. It's become a small industry. Scientists from around the world are searching for proof. Many ideas have been formulated based on the evidence that there's an invisible factor that makes galaxies rotate faster than expected, that there's a force that makes clusters of galaxies bend and distort starlight more than they should, and that galaxies and galaxy clusters in the early universe formed without enough gravity to pull together the clouds of ordinary matter. Nobody really knows what dark matter is, but scientists know what it is not. Ordinary atoms that make up both you and the visible world around you. What we know is that we don't know what 25% of the universe is made of. Scientists classify it as dark matter, since we do know that the measurements of the celestial background show that 5% of the matter is visible matter and energy, and 25% is dark matter. Even so, together these make up only 5% of the universe. Dark matter is explained one way to be a weakly interacting massive particle bumping into an atom of ordinary matter, emitting a flash of light and a slight electric charge. Another thought is that it's the result of two weakly interacting massive particles colliding with each other, causing the destruction of both, in turn producing a burst of gamma rays with detectable particles. Some questions being asked are, is dark matter a property of space, which has its own energy? Is it a new dynamic energy field that fills all space, but has the opposite effect of matter and normal energy? Is a new theory of gravity required which would affect the behavior of normal matter in galaxies and galaxy clusters? Or does it have a connection to the Higgs boson, possibly linked by the formation of new weakly interacting particles, or by the invisible decay into dark matter particles? Fortunately, there are a large number of dedicated scientists with the desire and patience to search the universe one particle at a time. Many have worked for more than 20 years at the task, although most of us have only known about the mystery for a short time. I will be discussing 4 of the facilities that are currently searching for dark matter. They are very different in many respects, but all have the same goal. And when, or if, found, the discovery would open the floodgates to a whole new field of physics. The Large Underground Xenon Experiment, located in South Dakota, is 1 mile underground to eliminate any interference with background signals caused by cosmic rays. It's a time projection chamber, which is a traditional detector design dating back to the 70s, and uses liquefied ultra-pure xenon. Interactions inside create an amount of light proportional to the amount of energy deposited. That light is then collected on rays of light detectors. This has a good chance of detecting the tiny bump of a dark matter particle with an atom of xenon. The Large Hadron Collider, located in a tunnel beneath the ground near Geneva, Switzerland, is the world's largest and most powerful particle accelerator. It consists of a 27-kilometer ring of superconducting magnets with a number of accelerating structures to boost the energy of the particles. Its aim is to allow physicists to test the predictions of different theories of particle physics and high-energy physics, and particularly prove or disprove the new theories. The Higgs particle was confirmed in 2013. The Alpha Magnetic Spectrometer is located at the International Space Station, 200 miles off the ground. It was launched to find dark matter in the vacuum of space. It's a giant particle detector designed to measure antimatter and cosmic rays, and to look for antimatter produced when dark matter particles collide. It does not have the interference that's inherent in ground-based facilities. The Fermi Gamma Ray Space Telescope is a spacecraft that carries the Large Array Telescope and the Gamma Ray Burst Monitor. It travels in a low, circular orbit around the Earth and maintains its position so that the instruments look away from the Earth. Among other things, one task is to look for dark matter by looking for an excess of gamma rays in the universe. Researchers map the gamma rays in the galaxy and try to account for all the gamma radiation found, then study the remaining radiation that cannot be identified. This process requires extremely precise mapping of the gamma radiation to get the accurate data. These facilities each have a uniqueness that allows them to hunt for dark matter in different ways, yet explore the same cosmos. This is an extremely exciting time in the field of particle physics. No one has yet isolated a particle of dark matter, but it hasn't weakened the determination of scientists to confirm its existence. Time will tell whether the missing piece of the puzzle, the search for the invisible and elusive dark matter, will be what has been theorized or will be an unexpected discovery. And maybe then we can move on to find the missing piece of some other mystery.